Hey guys, welcome to our very last video that we're going to have before the AP test. Looking back over my review videos, we've covered lots of stuff. We haven't covered everything in the review videos, but we've covered a lot of really big topics. The one kind of big topic that I haven't touched on very much is related rates. So I want to do that, and I just want to go over some simple derivatives and integrals. Sometimes when we get so bogged down with the crazy stuff, we mess up some of the easier stuff. So I want to go through a couple of those things. Okay, related rates. When we have, sometimes it's hard to recognize when a problem is a related rate problem. But whenever we have aspects of a shape or an equation changing, right? So we have different rates of change, and they'll ask you, what is the rate of change of the area of the triangle at the instant when the base is 10 or something like that, right? That's kind of key that we're looking for related rate problems. Okay. So let's just kind of look at one and then remember our strategy on how to do these. So let's say this. Let's say we have Origin High School. Okay. Okay. So we have Origin High School. Student A is is 12 miles or 12 meters east of the school, walking east at 7 meters per second. Student B is 5 miles north, or 5 meters north, walking south at 6 meters per second. At that instance, what is the rate of change of the distance between them? Oftentimes these problems are quite wordy, so we kind of have to distill this information into a know column and a need column. Oftentimes drawing a picture here will help you. So let's think about what we know. Let's put it in a picture and try and figure this out. Okay, first off, let's start with student A. Student A is 12 meters east of the school. So we're going to put student A right here. 12 meters east of the school. And that student is walking east. So that student is going this way. Okay. Whenever you see north, east, west, south, those kind of things, we're usually going to be dealing with right triangles. Okay. So again, there's student A. I am going to think of this side of the triangle as A. Student B is 5 meters north, so a little bit closer to the school. Here's student B. The student is north of the school, but is walking south. So again, I'm going to call this side of the triangle B. The question is, what is the rate of change of the distance between them? Well, the distance between them is the hypotenuse on this right triangle. And we should probably name that a letter because it's going to be changing, right? We name letters to things that are going to be changing in the problem. If something was constant, like if it was a ladder sliding down the wall, and the ladder is 15 feet long, I'll just call the ladder, the hypotenuse, 15. But since this distance between the students is changing as the students change, I'm going to call it variable C. Okay. Now, when we list our no column, we need to think about amounts versus rates. Rates are always going to have a time unit associated with it, right? 7 meters per second is a rate. 12 meters is just an amount. So what we know now in this triangle is that side A of the triangle right now is a length of 12. So I'm going to let A equal 12. What I want to know is, what is the rate of change of A? Is that something I know? Well, the rate of change of A would be how fast the student is walking. The student is walking at 7 meters per second. But what I want to know is that side of the triangle A getting bigger or smaller? Since the student is walking away from the school, the side triangle A is going to be getting bigger, so I'm going to say dA dt equals 7. Okay. Now let's list what I know about student B. Student B is 5 meters north. That's just an amount, so B equals 5. I know that student B is moving at a rate of 6 meters per second. But the key here is student B is moving south. Okay? Because this student is walking this direction, that side of our triangle is actually going to be decreasing. So I'm going to say dB dt equals -6. If the student was walking away from the school, then I would have made that a +6, right? What we need then is usually what we need is a rate of change, not always, but usually what we need is a rate of change. It's a rate of change of the distance between them. I called that C. You can call it whatever you want, but I'm going to call it dC dt is what we need. Okay? I usually stop now and think about, okay, is there anything else that I can add to my no column that wasn't explicitly stated? Well, I know if A is 12 and B is 5, that using the Pythagorean theorem, C must be 13. That's a Pythagorean triple. It's helpful to know 5, 12, 13 and their multiples. Also 3, 4, 5 and their multiples. The other common ones are 8, 15, 17 and 7, 24, 25. So right away I know C has to be 13 at that instant. Now if I don't find that right then and there, that's okay. It's going to come up as an unknown that we're going to have to solve for later. But it helps to anticipate that ahead of time. Okay, after my know and after my need, I have to get an equation that relates the three. Now, sometimes they'll provide you an equation. Sometimes they won't. Things that you need to know for sure. You need to know area and circumference of a circle. You need to know area and perimeter of a square, area and perimeter of a triangle, things like that. Things that they'll give you. Spheres, they'll give you both surface area and volume. Cylinders, they'll give you surface area, volume. And if it's anything else bizarre, they'll give you a formula. But sometimes they give you two formulas, right? Some of these problems are pretty tough, right? Sometimes you have to end up doing two related rates, right? Maybe you need to get the dx dt, and then you have to get dA dt or something like that. Right? Sometimes you have to do a couple things. Sometimes it's more straightforward. The equation here that relates the sides of a right triangle to each other is one of the most important equations in all of math, and that's the Pythagorean theorem. You will absolutely be expected to know the Pythagorean theorem. So here we know our equation would be a squared plus b squared equals c squared. After we get our equation, we want to do the derivative of that equation. When we do so, Remember, after we do the derivative, you don't plug anything in now. After we do the derivative, just remember that each time we do the derivative, it's like implicit differentiation. So the derivative of a squared, well, that's 2a, but I have to tack on dA dt plus 2b dB dt equals 2c dc dt. Also, when you do the derivative, right, if you need to do a product rule, do a product rule. If you need to do a quotient rule, do a quotient rule. If you need to do a chain rule, do a chain rule, right? Just let the equation kind of dictate how you do that derivative. Just make sure anytime you're doing a derivative, you're being careful and knowing your rules. Okay? The next thing I would do to make this problem a little bit easier, I know I can divide by 2 in this equation because all the terms have a 2. So I'm just going to cross them all out. Okay, now I'm going to carefully plug everything in. A, I look back to my column, A was 12, dA dt was 7, B was 5, dB dt was negative 6, C was 13, and dC dt is my one unknown. Now, after you do the derivative and you plug in, if you end up having two things unknown, right, there's got to be a way to get the other thing that's unknown, right? Not the thing that you need, but the one other thing that shows up. For example, if we didn't stop and consider C, we would have an unknown for C and dC dt, but we'd say, hey, I know how the Pythagorean theorem works. I can figure out what C is at that instant, right? Or, hey, I need the radius of this thing, but all I have is the circumference. Well, if it's a circle, you know how the circumference is 2 pi r, and you can figure out what the radius is given that circumference. Or you know the area, and you know, okay, if the area is this, area equals pi r squared. You can figure it out that way. Okay. Now again, if we're in free response, I would just divide by 13 and leave it very unsimplified. If this wasn't free response, I'd say, okay, 84 minus 30. 84 minus 30 is 54, so it's 54 over 13. My next question for you is the distance between the students increasing or decreasing? Well, since the distance between the students is c, and the derivative of c is a positive number, we would say at this instant, the distance between the students is increasing. If I would have gotten a negative number, then I know the distance between the students is decreasing. Okay? What if they would ask the same question, but they wanted to know the rate of change of the area of the triangle? Well, everything else would be the same here, except my need would be the area of the triangle. Okay? And I know area equals, on a triangle, half base times height. But I'm not going to use B and H because my base I called A, and my height I called B. Right? Or half AB. Now this would be an unfortunate letter choice to use A and B here, because I usually use capital A for area. Okay? So I'm just going to leave area as this word area, so I don't confuse it with A. Okay? So d area dt now I have to derive this thing. Well, I have function times function, so I know this is product rule. So I do the derivative of the first term. I'm going to call the first term half A, and I'm going to call the second term B. The derivative of half A is half dA dt. That's the derivative of the first, times the second, plus the first, half A, times the derivative of the second, dB dt. So my rate of change in my area would be half of 7 times 5 plus half of 12 times dB dt, I think was negative 6. So my rate of change of area would be 35 over 2. And this is going to be minus 36. If I needed to simplify, it'd be 35 minus 72 over 2. 72 minus 35. 12 minus 5 is 7. So my answer would be negative 37 over 2. Since the area dt is negative, that means the area of the triangle is decreasing at that instant. So the area is getting smaller at that time. Okay, let's just do some simple derivatives, simple integrals. Remember, with derivatives, the power rule if I'm doing the derivative of ax to the n power, I take this n and I multiply it out front, and I get an x, and I reduce the power n minus 1. So some derivatives. If f of x equals 2x to the fifth, f prime of x would be 10x to the fourth. Again, very simple here, but we just want to make sure we do this right on the exam. Some power rules that are a little bit trickier. If f of x equals 7 root x and I need to do the derivative, well, I want to put it in ax to the n form if I can. Well, we know square root is the same as half power. And then I know I can move that up and call this 7x to the negative half. Now again, I multiply out front. 7 times negative half is negative 7 over 2 x, and I reduce the power by 1. Negative half minus 1 is negative 3 halves. Now again, if all we need is f prime of x, we're good there. But if we have to evaluate this thing, we want to evaluate it with positive exponents. So I'm going to take this x to a negative power and move it down to the denominator with the 2. So now if we need to plug in a number, like let's say we needed f prime of 4, well, I know that's going to be negative 7 over 2 times 4 to the 3 halves. Well, how do I evaluate this without a calculator? Well, that tells me the type of root, so I'm going to do a square root of 4 is 2, and then I'm going to cube it, and I'm going to get 8. So 4 to the 3 halves is 8. 8 times 2 is 16, and I'm going to get negative 7 over 16 is my final answer. Okay? How about this? F of x equals 6 over x. Well, find f prime of x. Well, the first thing I want to do is put this in ax to the n form. This x is to the first power. When I move it up, I get 6x to the negative 1. So when I do my derivative, I get negative 6x to the negative 2, or negative 6 over x squared. This is going to be a better way to evaluate that. With 6 over x, you might be thinking, oh, isn't that natural log? No, no, no. The derivative with x on the bottom, right, is not natural log. That's the integral. The integral of 6 over x is going to be 6 natural log absolute value x. Okay? Let's talk about product rule, quotient rule, chain rule again really quick. If I have to do the derivative of f of x times g of x, I must do the derivative of the first times the second plus the first times the derivative of the second. So if I know that f of x equals 2x squared cosine x, to do f prime, I'm going to need to do the product rule. I do the derivative of the first, which is 4x, times the second, cosine x, plus the first, 2x squared, times the derivative of the second, which is negative sine of x. Okay? I strongly suggest you rewrite this so it doesn't look like we're subtracting. It looks like we're multiplying by a negative. I'd write this as 4x cosine x minus 2x squared sine x. Okay? Product rule. Quotient rule. Again, if I have to do the derivative of f of x over g of x, it's going to be the derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the bottom function, whole thing squared. Something to keep in mind, when you do the quotient rule, if you're analyzing whether the derivative is positive or negative, your denominator here will always be positive, because whatever g of x is, when I square it, will make a positive number, unless g of x is 0, which our function will be undefined anyways. Okay? So really, we just have to analyze the top. If we want to determine where this thing is plus or minus, just determine where the numerator is plus or minus. Chain rule. When I do the derivative of f of g of x, I do the derivative of the outer function with respect to the inner function times the derivative of the inner function. Example. If I have to do f of x equals sine of 3x, f prime of x, I would do the derivative of the outer function, cos, with respect to the inner function, 3x, and then I'd multiply by the derivative of the inner function, and I'd get 3. E works kind of interestingly. Let's say I have f of x is equal to e to the tan x. F prime of x would be the derivative of the outer function. E is its own derivative with respect to the inner function, tan x. It's going to start off e to the tan x. E always starts off just as it is. But now we have to multiply it by the derivative of tangent x, which is secant squared x. Okay. When we do simple antiderivatives, our base, right, our normal way of doing it is called bump and divide. I call it bump and divide. So we bump our power and then divide by our new power. The antiderivative of 8x cubed would be we bump and divide. 8 divided by 4 is 2. If it's an indefinite integral, I have to put plus c. If it's a definite integral, I'm going to plug in the top, plug in the bottom. Let's try a couple more. Okay. If I want to do this antiderivative, again, it's going to be a bump and divide. It's going to help me to rewrite this thing first as 4x to the half. Notice, I still wrote the integral sign because I still haven't done the integral. All I did was rewrote it, so it's going to be easier to do the antiderivative. Okay, then this is going to equal, I need to bump the power. Half plus 1 is 3 halves. And then I have to divide by 3 halves. Well, dividing by 3 halves is the same as taking 4 and multiplying by 2/3. When I multiply them together, there's nothing to cross cancel. So I get 8/3 x to the 3 halves plus c. Let's say I have to do this. The integral from 0 to 3 of t squared minus 6t plus 1 dt. I'm just going to go ahead and bump and divide my way through this thing. It's already in at to the n form, or ax to the n form. So I bump and divide. I bump and divide. What happens when I have a constant? Well, with derivatives, it goes away. But a constant, when we're doing an antiderivative, we tack on an x, or in this case, we tack on a t. Okay. So we get our antiderivative. Again, you can double check, do the derivative of this. Well, the derivative would be 3 times 1/3 is 1, so I get t squared minus 6t plus 1, which is exactly what I have up here. Okay. Now all I have to do is plug in 3 and plug in 0 and subtract. So when I plug in 3, I get 1/3 3 cubed minus 3 times 3 squared plus 3 minus, now you can see when you plug in 0, everything is going to be 0 here. I'm just going to say minus 0. Be careful though, when your lower limit on your integrals is 0, don't just assume plugging in 0 makes 0. It does with those polynomials, okay? But if I plug in, if I have a cosine of 0 is 1. If I have e to the 0 also equals 1, okay? Now, if it was free response, I'd box that answer right there. If it was multiple choice, I'd have to hammer this thing down. 3 cubed means 3 times 3 times 3, which is 27. 27 divided by 3 is 9. So I get 9 minus 3 squared is 9. 9 times 3 is 27. Plus 3, 9 minus 27. Right, 9 minus 27. You might not know it off the top of your head. Just do 27 minus 9. We get 18. But since this one's bigger and it's the negative, we get negative 18 plus 3, which equals negative 15. Okay. That is it for today. Hopefully you make it to the review session today and study tonight, but also get a good night's sleep and be ready. Make sure you come to school on time tomorrow. If you show up late, they won't let you in. So be there early, be there ready to go. I believe in you guys. You can do it. Just remember 2 chains. Bye.